What's up, everybody? Here's another video on molarity and dilutions. Here we go. Let's take a look at my first question here. How many grams of solute are in 57 milliliters of a 1.1 molar calcium chloride solution? Okay, here we go. First thing we need is to figure out what we need. So we need grams. Okay, and I'm starting at volume and I have molarity. So let's use our info here. If I have volume and I have molarity, I can get moles. Remember the equation, molarity times volume equals moles. So literally it's just a multiplication problem. Ski yeet, here we go. I have 1.1 molars. That's moles per liter. So moles per liter times liters cancels out liters. So we're gonna multiply, careful, not milliliters. We need to multiply liters. So we're going to multiply by 0.057 liters. The other way you can do this is ratios. 1.1 moles over 1 liter equals X moles over 0.057 liters. Same thing. You just cross multiply and you get this. So either way works. Let's do the math here. Let's math it out. I got 1.1 times 0.057. And I'm getting 0.0627. Not a lot of moles there. Now, how do I get moles to grams? Y'all better know this. You multiply by molar mass. So once I'm at moles, I multiply by grams over 1 mole. Cool. Calcium chloride. Well, calcium's around 40. Chlorine's around 35.5, so that's 40 plus 71. So we're talking a molar mass of around 111 over here. Now, I'm just approximating. You have the perfect number, but there's 111 grams per mole. So cancel out moles, and you get 111 times 0.0627, and I get 6.959 grams. So let's just say 6.96 grams. And that's how many grams you have. Remember, moles is not grams. If you get like 0.006 grams, that's probably not right. You're probably going to get a number like 5 or 6 or 9, something like that. So keep that in mind. Let's look at our second one. Skeet, how much water must you add to 30 milliliters of a 15 molar stock solution to make the molarity 0.5? So in this case, we have a dilution. We're basically taking a stock solution, which means very, very concentrated, and we're pouring water into it till it dilutes. How much water? Let's find out. First thing you got to figure out is what equation to use. Well, if you're given 2 concentrations or 2 volumes, you're going to use C1V1 equals C2V2. Some of you, like I said, might have said M1V1 equals M2V2. Either way is fine. C means concentration. C1V1 equals C2V2. Well, what's my first concentration? Remember to match things up correctly. So, how much water must you add to 30 milliliters of a 15 molar? Okay, so if I have 30 milliliters of 15 molars, I'm going to match those together. So let's do it. Concentration 1, 15. Volume 1, 30. Remember, you can keep this in milliliters. Your answer will just also be in milliliters. Equals. Okay, concentration 2 is going to be 0.5. This is going to be a huge number we need. We don't know volume 2. You're going to need to add a pretty large amount of water to get the molarity this small. Remember, the more water you add, the lower the molarity. Inverse relationship, concentration up, volume down, or concentration down because volume goes up. So let's do this. 15 times 30 divided by 0.5, which is the same thing as multiplying by 2, and I get 900. Wow, 900. Now, volume 2 is 900, but that is not how much water you add. 900 milliliters is where the end volume is. You started with 30 milliliters of your stock solution. So you're not going to add 900, you're going to add a specific amount until you get to 900. So, using subtraction math, 900 minus 30, if you start with 30, you're going to add 870 milliliters to fill it up that much. So my answer to this question is 870 milliliters. And that's how much water I add to make a very dilute solution from a stock solution. Hope that helped.